just some review about the SAT, specifically the math section. You guys should be pretty familiar with this already from either practice tests or the PSATs that you might have taken. But there are two math sections. Each section has 22 questions and 35 minutes for each. You do get to use Desmos the whole test, or the whole math section, I should say, which is a super powerful calculator. If you guys aren't familiar with it already, it would definitely be worth it to take a look at that outside of this. There's a specific SAT calculator that they use. So you just have to search up Desmos SAT and it'll pop right up. But just make sure you guys get familiar with that. And then, as you guys should know, math has both multiple choice and open response questions. And the topics that the SAT really covers are going to be broken down into four content areas. It's going to be algebra, so what we're covering today, which is going to be a good majority, as well as advanced math, which we'll cover later in the week. And then they are also going to ask problem solving and data analysis questions and geometry and trig questions. Again, those will be a little less, they will have less content covered. So when you guys are studying, it shouldn't necessarily be the prime focus of your concern. Okay, so that's about the digital SAT. Again, if you guys have questions, feel free to put them in the chat or raise your hand. Yeah, so all right, so we're going to jump right in with some systems of equation review. What I'm going to do for this is I'm going to go through and walk you guys through the problems. If you want to do them on your own separately and drop an answer in the chat, or thoughts, questions you have about the slide, feel free to do that. But yeah, so systems of equation, the first method that you guys probably learned to solve these is going to be substitution. So substitution is going to be when you isolate a variable and then plug it into the other equation and solve it. So for this question specifically, they set it up really nicely. They already have the y isolated on this side. And the fastest way to do this is going to be to plug this side of the equation in for y in the other equation. A different way you can do it if they don't set it up that way, or if you just prefer, is to also isolate y in this equation by subtracting 4x from both sides and then solving. So using the first method, plugging in 3x minus 1 for y, it's going to look like 4x plus 3x minus 1 is going to be equal to negative 8. You're going to combine the like terms to get 7x minus 1 equals negative 8. When you subtract, when you add 1 to both sides, sorry, you're going to get 7x is equal to negative 8 plus 1, which is negative 7. And then you divide both sides by the 7 right here to get x equals negative 1. And then in substitution or elimination, no matter how you solve these systems of equation questions, what you're going to do once you find this first solution is you're going to take whatever this is and you're going to either plug it into the first equation or the second equation that you have. So just because it's how I want to do it, I'm going to choose the first equation. So I'm going to write it out and plug in negative 1 for x. And this is going to get negative 3. And then negative 3 minus 1 is going to be negative 4. So, and remember, important on the math questions is you're going to want to make sure you remember to give them the answer the way that they're asking for it. So in this question, they're asking for it in this XY form. So just make sure to write your answer like that. And it's going to look like this. A way to double check that is I picked the first equation to plug our x value into. You can choose this. You can also plug that x value into the second equation. You can also use Desmos to double check this by plugging in these two lines and then finding their point of intersection. So I don't see any chat notifications. So we're gonna go ahead and move on. All right. All right. And then the second method is going to be elimination. So elimination to solve a systems of equation, what you are what's going to be important is multiplying to get the same coefficient into equations on the same variable. Mm, right. So on a lot of these systems of equation questions, when you solve using elimination, the SAT is going to make you do that multiplication to get the same coefficients on the terms. However, in the two that were given in this question, they set it up for you really nicely because the y's both have the same coefficient of 1. So using that, and then once you get get the same coefficient, you're going to either add or subtract the two equations. And whether or not you add or subtract really depends on you can use either method for any set of equations that they give you. What's going to make it the easiest is if you know that you add when the signs are opposite on the coefficients that are the same between the two equations, and then you want to subtract when the signs are the same. So we know that this equation already has the same coefficients on one of the terms, which is going to be the 1 on the y, and that their signs attached to those terms are opposites. So that means that we're going to go ahead and add these two equations, and then you just add the like terms. So this will give you 5x, and then -1 plus +1 is just going to be 0. So there's not going to be anything there, equals 8. So, or not 8, sorry, 15. So rewriting that without the space for the y term, it's going to be 5x equals 15. Then you just divide by 5 on both sides, like usual, to get x equals 3. And this is easy. Again, you're going to want to remember to read the question very closely. Make sure, one, that you're giving them the answer in the form that they're asking for, but also that you're giving them what they asked for, because in this question, they're just asking you to solve for x. So you can stop right here. You don't need to further solve for y. All right. So that's how you use elimination. Again, these past two were set up really nicely for us, but we are going to get to some practice with ones that we have to do all of the steps on. So if there are no questions, I'll go ahead and keep going. Okay, so this is probably more similar to what you guys are going to be seeing as these types of systems of equation questions. Right? So they give us two equations and they're asking for us to solve the system. And right here, this is the information they want us to solve for. They want us to solve for both x and y, and they want us to give it in this point form. So knowing that, on any systems of equation question, you can use any method that you can use whatever method you prefer. So for this one option would be to use substitution. And then, of course, this has a couple different ways you could do it. You can isolate x in the first equation. which is going to be the easiest way to solve it by substitution, or you could isolate y in that first equation and then do the same thing on the second equation. If you guys are going to do elimination, again, probably the fastest way to do it would be to multiply this first equation by, and then when you're multiplying this first equation, you could either do it by 7 or by -7. And the only thing that this negative multiplication is going to change is whether or not you add or subtract these two equations when you're actually going to solve. Of course, then you can also, don't forget, use Desmos to solve. Just as a note, I'm going to make sure to go through and do all of these questions out, like the long way algebraically, just to make sure that everybody understands why and how and what that looks like. But on the test, my best advice would be to use Desmos to solve all the systems of equation questions, because you just have to take these two equations that they give you, plug them in, and as long as you know how to read the graph of a systems of equations, then it's going to be really fast to find the answer. Right, so, but like I said, doing it out algebraically, we have a bunch of options. Just personally, I like to do substitution. So I'm going to isolate x on the first equation. So I'm going to add 2y to both sides to get x equals, and I'm going to move it around a little bit just so that it looks a little bit nicer, x equals 2y minus 2. And then I'm going to take this 2y minus 2 and plug it in for this x right here, which will give us 7 times 2y minus 2. It's going to be minus 3y equals 19. And then you just multiply out. Minus 3y equals 19. Then you combine the like terms. I'll continue down here. So 14y plus or minus 3y is going to be 11y minus 14 is going to be equal to 19. And then you're going to add 14 to both sides. And you're going to get 11y equals, so positive 33, and then 11, or 33 divided by 11 is going to be 3. And then, like the other questions, you're going to take this y equals 3, half of the solution, and you're just going to plug it back into one of these two original equations. So again, I'll plug it back into the first equation because the math will just be a little bit nicer. So it'll be x minus 2 times 3 equals -2. Multiply out to get x minus 6 equals -2, and then you add 6 to both sides to get x equals positive 4. And then again, make sure that if this is an open response question, you write the answer how they give it to you or how they ask for it, which means that the final answer for this is going to be 4, 3. All right. Again, I'm just kind of breezing through these ones because they are things on a physical calculator. Yes, you could if you have a graphing calculator. I believe a TI-84 does graph. I'm not quite sure though. Yes, so you can find, you're gonna want to find the answer on a physical graphing calculator, you can use these two equations similarly to how you would in Desmos. To use a physical calculator that doesn't have the graphing component of it, you will need to solve this system and get at least one solution. And then you can use the calculator function to plug the solution back in to find the other variable. But good thing I actually am not sure how they do this on the now that the test is digital. But you probably won't be allowed a physical calculator at all. They'll will just have the option for the digital calculator. To answer your question, Marlisa. Of course. Yes. Okay. Good question. All right. Anything else before I move on? Just feel free to drop it in the chat if you think of it now, or if you think of it as I'm going through, just feel free to pop it in there. We're going on to the next problem. Okay. So the SAT is notorious for their love of word problems. And they're going to give you word problems covering all areas of content. So that's just important to know. And it's important not to get too freaked out by word problems, because if you know how to interpret them and know what you need to find from the question, they're actually pretty easy. So this question says that a group of 41 people go to a concert together in 7 vehicles. Some of the vehicles can hold 7 people each, and the rest can hold 5. Assuming all the vehicles are filled to capacity, exactly how many of the vehicles can hold 7 people? So we know this is a systems of equation question because it's in the systems of equation lecture. But if you're on the test, that should also be something that is pretty fast for you to identify, which will help us start to solve the problem. So if we know that it's a system of equations, we know that we're going to have 2 variables and also 2 equations. Right? So, and then we have to determine what each variable is going to correspond to, which means we need to go back to the question. So this last sentence is where you're going to find what they're asking us for. So it says that assuming all vehicles are filled to capacity, exactly how many of the vehicles can hold 7 people? So what they're asking is this last bit, how many of the vehicles can hold 7 people? So we're going to use that to start to solve the question. And okay, so they're looking for one that has 7 people. So we'll say that Y are vehicles that can hold 7 people. And then we know that the other part is going to be cars that can hold 5 people. So we'll make X the 5 people cars and Y the 7 people cars. Yes, okay. All right, and then once we have that out, we're going to go back again to the beginning part of the question and pick out the rest of the information that we're going to use to build these equations. So it says that a group of 41 people go to a concert together in 7 vehicles. So there are 41 people total and 7 cars total. So when they give you two like total amounts, what that means is that for the equations, one of these is going to be equal to 41 and one of them is going to be equal to 7. Okay, so we have the part of the equations to the right of the equal signs, and now we need to create these left parts of the equations. So we know that some vehicles can hold 7 people and some vehicles can hold 5 people. So this part is going to be important for the total number of people, right? Because it's telling you how many people fit in each car. So we're going to use that to help fill in equation number 2. So if we have, okay, so if we have X amount of people and then Y, and then we have 2 variables for X and Y. So we know that if X is the number of cars that can hold 5 people. We're going to multiply that number in this equation by 5 because we're looking for the total sum of people. And then similarly, we're going to do the same thing for y. So we plug 7 in there. And then for this equation number 1, it's the total number of cars. So because it's the total number of cars, we can just add up x and y. And let me just make this a little bit more clear. Okay, just make this a little bit more clear that this is the number of 5 people, cars, and then this is the number of 7 people, cars. Right? So we're using the information in the equation or in the question to build the equation. C. All right, we have a bunch of people saying C. Good, so I'm going to mark that down. I will mark that down. Okay, so people, we have lots of answers for C. Okay, so using these two equations, we're then going to solve. So x plus y equals 7 and 5x plus 7y equals 41. Again, this is going to be easiest to do by substitution. And so in these word problems, if they're not asking you for like a point or for you to add the two values together, then you're going to want to make sure you go back to the question and look at what they're asking. So they're asking how many of the vehicles can hold 7 people. And that's going to help us know how to solve this. So if y is the number of vehicles that can hold 7 people that we're solving for, then we are going to want to solve for y. So in that case, for substitution, I'm going to go ahead and isolate x to get x equals 7 minus y. And then I'm going to plug that back into, or I'm going to plug that into the second equation to get 5 times 7 minus y is going to be equal, plus 7y will all be equal to 41. All right, so then you multiply out 35 minus 5y plus 7y equals 41. Continuing it over here, I'm going to combine like terms. So it's going to be 35 plus 2y equal 41. Subtract the 35 from both sides. So 2y is going to be equal to 5, 6. So, and 2y equals 6 divided by 2 is going to be y equals 3, which makes the answer C. So everybody who said that in the chat, you guys are correct. Good job. All right. And if there are no questions, I'm going to go ahead and move on to the next slide. Okay. All right. So up until this point, we've just been solving systems of equations that have one solution. But we know that from your algebra class, there are actually 3 types of systems of equation solutions. So, like I said, we've been looking most entirely at this first one for these last few practice problems, ones that are going to have only one solution. So we know that the solution to a system is going to be the point of intersection to any system. So for this one, when the lines are completely different, when the lines are completely different and they have different slopes and different y-intercepts, it's just going to be one solution. With this type of line, it's important to remember the vocabulary for it because the SAT loves to use it. They will call it consistent and independent lines in word problems. Or they will give you a set and say, oh, this set is consistent and independent, and ask you something about the number of solutions or what the solutions might look like. But of course, there are two other possible types of solutions for systems of equations. The next one is going to be no solution, and these are lines that never touch. So for lines that never touch, that means that they are going to be parallel. And in a word problem, you're going to see it as inconsistent. Now, something that's important to remember when you're thinking about parallel lines and using those on the test and using that information on the test is the rules about what makes lines parallel. So the two rules for parallel lines, if you guys don't remember, is that their slopes are going to be the same, but their y-intercepts are going to be different. So in order to be parallel, a line has to meet both of these rules. If it doesn't meet both of these rules, then they're not parallel, and there will either be one solution or no solution. So, and then in a word problem, like I said, they'll call that inconsistent. And then the last option for the number of solutions you can get is going to be this third graph, which is infinitely many solutions or the same line. In a word problem, they are going to call these consistent and dependent. And usually you'll be able to tell because the lines will be, the coefficients of the two equations will be multiples of each other. So if you have one equation, all the coefficients multiplied by 2 would be the second one, which would give you the same line. An important thing to note with these, the difference between these no solution and infinitely many solutions is that the slope for two equations with the same line or infinitely many solutions, the slope is going to be the same actually. The thing about it is that they are going to have the same y-intercept as well. So m will be equal to m and b will also be equal to b. And then for this first one, thinking about these relationships between slopes and the y-intercepts, it is the slopes are going to be different and the y-intercepts are usually different, but sometimes that is the point of intersection. So, all right. So now that we've had a little bit of a refresher on that, we're going to move on to some practice problems that use some of this terminology to get you guys a little bit familiar with what that might look like. So first we have a system of two equations, or one of the two equations in a linear system is 2x plus 6y equals 10, and the system has no solution. Which of the following could be the other equation in the system? So they tell us, so first off, they're asking us to find the other equation in the system. So all of these, our answer choices give us a hint that that's what they want. But then they also give us some important information. So they give us the first equation, and then they also tell us that this system has no solution. So if they tell you that it has no solution, your first thought should be that the slope of whatever the second equation is and the y-intercept in whatever the second equation is, the slope has to be the same as this first equation that they give us, and then the y-intercept has to be different. So a good way to do that, and they're going to give you a lot of these systems of equations in this form of ax plus by equals c, which is a little bit different from the y equals mx plus b form that you guys are probably most familiar with. See what people are saying. People have answers. Here, A and D. Okay. I'll keep going and we'll see which one of those is correct. But so, right, you guys, like I said, you guys are probably most used to seeing y equals mx plus b, which from this form, it's easy to look and see if the slopes are the same and if the y-intercepts are the same. But in this form, it looks a little bit different, obviously. So a good way to tell that the y, a good way to tell if so you can rewrite it. You can do the whole 6y equals negative 2x plus 10 thing, and then divide the whole thing by 6 to get some answer. And then you can look and see, what that corresponds with and what that looks like with the multiple choice. That's going to be a little bit more work for you guys. Because, so we know this, but looking at what that means for this form of equation, in this equation, the term without any variable attached to it is the y-intercept. So knowing that, it's a good cheat to know that this term on to the right of the equal sign in these types of equations is usually going to be your y-intercept. And if it's even if you obviously you will have to divide by these two to solve it out like this. But so that's the first step. So the y-intercept is 10, and then that's going to be divided by 6. But looking and seeing, are any of these 10, to see if we can eliminate any answers right off the bat. So we see that this is going to be 10, so it's probably not going to be D. So to people who said D in the chat, D is not going to be correct. But then, so once we know that, we have that eliminated. Let's look at these other equations. So people say A. All right, so we say I saw people say A in the chat, and it's actually not going to be A because A is going to give us the same line. And we know this because if we divide the equation they give us by 2, it's going to give us this equation, which would make it the same line. So if we also know that it can't be A, then we have to look at the relationship then we have to start looking at the slope. So a good way to do it, the relationship between the slope, if these equations without any variables will look like this, or without any constants, coefficients will look like this. So if this is like the skeleton form of these equations, the relationship between the slopes you can check by doing A over D is equal to B over E. So, and we have the top of that, it's going to be 2 over something is equal to 6 over something. And then plugging in the options that they give us for the equations here. So if it was going to be B, it'd be 2 over 1 is equal to 6 divided by 3, which would be 2 is equal to 2, which is true. But let's also try C. C would give us 2 over 6 is equal to 6 over negative 2, which is not going to be equal to the same thing. So using that, and if we know that it has no solutions, which means the lines have to be parallel, which means they have to have the same slope, it's going to mean that the proportion we did out for B is going to give us the correct answer to this. Now, for people who put other answers in the chat, do you guys understand why it would be B instead of A? Yes, okay. Perfect. Alrighty, in that case, we're going to go ahead and move on to this next question. So they give us a system of equations, and then they ask us Which of the following options accurately describes all solutions to the systems of equations that they give us? So they give us two options for a solution, one solution, and then they say infinitely many and no solutions. So looking at this, you can do this out the long way and plug it. You can either use substitution, elimination, or Desmos to do it out the long way. But it might also be worth it just to further isolate y on this side of the equation, um, and see where that gets us, because that's also going to help if you guys decide to use one of these methods. So if we want to further isolate y on this side, we're going to divide this whole equation by 6 to get negative x plus 3 equals y. And so looking at this, now that we've fully isolated the y variable on the right side of that equation, yes. Yeah, I'll show you guys one in Desmos. Yes, so I hear C in the chat for this. See a couple of times. Yes, exactly. So once you fully isolate the y, you see that it actually is going to give you the same equation as the first one. And from our review earlier, we know that if they're the same line, then the solution has infinitely many systems.
I have
And
a question. Why is
yeah,
it
go
not
for it.
A and B?
So it's not A and B because, um, oh, I think you joined a little bit late, but we talked about that. So systems of equations, you can get three solutions, and it's essentially where they intersect. So one solution is going to be if the lines intersect only once. No solution is going to be if they're parallel, and then infinitely many solutions is going to be the same line. And in this problem, so for this, in order to really start solving, you really want to fully isolate the y variable in the second equation. So to do that, you have to divide by 6, which will get you y equals negative x plus 3. And remember that if you have the same equation, it's going to be the same line, which is going to be infinitely many solutions. Does that make sense? Look at the chat. Okay. Yes. Perfect. Okay. All right. And so somebody asked to see this on Desmos. Okay. Mhm. Let's see. All right, I'm going to pause sharing my screen and I'm going to share my desktop with you guys. So we'll go to, and like I said at the beginning, there's a specific Desmos for the SAT test. So you just search up Desmos SAT, you click that. On the exams, I imagine that they will give it to you already pulled up. But then you're going to plug in the equations that they give you. So for the one that we were just doing, it's going to be negative x plus 3 equals y. And then they gave us negative 6x plus 18y is going to plus 18 is going to be equal to 6y. Great. So for that, like I said, because they're the same line, you can tell if you disable the view of one of them that it's going to be the same line, which would be infinitely many solutions. Alternatively, if we change this so that they're different lines, for when you guys see that on the test, the point of the solution is going to be the point of intersection. So usually they'll highlight that with one of these little gray um, dots. And so they do it here. So we know this is the point of intersection. And then they do that for the y-intercept as well of whatever line you have selected over here. So that'll give you the y-intercept here, and also the y-intercept of the second line. All right. I will go back to that. See what people said in the chat. Okay. Okay. All right. So we're gonna go ahead. Do you guys have any questions for me? You can put them in the chat or feel free to unmute yourselves. We do have some more practice problems, so don't worry. I we will be here until probably just about 6. But okay, I'm not seeing any questions, so we will keep.
Excuse me.
Yes.
I've been answering some of the questions. I'm just letting you know.
Sorry, you cut out. Oh, here we go.
I was answering some of the questions.
Hmm.
I was paying attention. I'm just letting you know.
Oh, thank you. Yeah, I see your answers in the chat here. Okay.
Oh,
So,
Miss Sam,
yeah,
my name is Parker. I'm the one who's speaking.
yes.
I'm also answering the questions.
Okay. Thanks, guys. You don't have to. I see your answers in the chat, even though I'm not responding to them. Okay. All right. So, our first practice problem. So, they give us the system of equations. 8x minus y is going to be equal to 12. And then, oops, 2x minus 6y is going to be equal to 3. If x, and then they ask if x comma y is a solution of the system, then what is the value of x plus y? So to do this, again, you can do this substitution, elimination, or Desmos, just as long as you get the right answer, obviously. But what I'm going to do is I'm going to use substitution. I just personally think that's the easiest. And then I'm going to do that on the first equation because y is already, the coefficient is already 1. So when you subtract 8x from both sides, it'll be negative y is equal to 12 minus 8x. And then you're going to want to make sure that you get rid of this negative on the y. So we're going to just divide the whole equation by negative 1 to get y is going to be equal to 8x minus 12. And then once you get this, again, you can just plug that in for y and solve. So it will be 2x minus 6 times 8x minus 12 is equal to 3. So 2x minus 48x plus 6 times 12 is 72 is equal to 3. So let's see what people are saying in the chat. 1.5. Okay. All right, guys. Just to say, just please keep it respectful in the chat. Everybody is here to learn. And since I am having you guys putting those answers in the chat, that's really what it's for. Thank you. All right, so we're solving this. It's going to be 2x minus 48 is going to be negative 44. X plus 72 is going to be equal to 3. So, and then it's going to be negative 44x is equal to 72 minus 3 minus 72 is going to be negative 69. And then it isn't giving me a nice answer. What did we say in the chat? 6 and 1.5. Remember, for the value of x plus y. Yes. For the answers, we have 1, 3 switches. We have 1.5. And we also have 6. All right. So this isn't giving me a crazy nice answer. Let's just go back and make sure I didn't make any mistakes. Plus 72. Okay. Yep. So 1.5. Okay. Yes. So this is going to give us, it's going to be 40 negative. So this is going to be x will equal negative 69 over negative 44. So x will be equal to 69 divided by 44. And I'm just going to keep it that way. That's not a great way to solve for this. Let's see what people are. Oh, somebody is coming in late. Okay. Yes. So again, if you go to do it using the algebraic method on the exam and it's giving you, especially if it gives you a question that has the answer is going to be fractions, my recommendation would be to go through and do it on Desmos. So let's see, ax minus y is 12. Equal to 12. And then it's going to be 2x minus 6y is equal to 3. 2, 3.
Forget.
Equal. So, yep. So the answer is going to be 1.5 and 0. So 1.5 plus 0 is going to be 0. I must have been doing something wrong in my math. If you could just mute yourself, Parker, please.
Parker, you're unmuted.
Okay. So moving on to the next problem. All right, moving on to the next problem, we are going to get. All right, so let's see how much time we have. Okay, we have a couple more minutes left. So in this linear function of h of 0 is equal to 41, and h of 1 is equal to 40. Which equation defines h? All right, before I go ahead and solve this, I'm going to ask you guys to go ahead and put your answer choice in the chat, because this should be a pretty fast question for you guys to solve. So I hear A, yes. So
I'm
I hear
confused. I got B. I don't know how to got A.
B. So for this question says that for this function, and they don't tell us what the function is, but they say when you plug 0 into this function, it's going to be equal to 41. And then when you plug 1 into this function, it's going to be equal to 40. So the way to do this is to really plug 0 and 1 into the functions that they give you here and see if you get the same answers. So for B specifically, if we plug in 0 for B, that gets us negative 0, which is 0. So that would mean that h of 0 is equal to 0, which we know is not true based on the information they give us in the question, so it can't be B. If we go on to C, if we knew negative 41 times 0, then that would also get us 0, so we know it can't be C. And then it can't be D because we have to have a variable in the function for us to plug those values into. So we know it can't be D, which only leaves A. And then if you want to double check how you got to A, negative 0 plus 41 is going to be equal to 41. So that would make this true. And then we plug in negative 1 plus 41 is going to be equal to 40, which would make this true, which would make A the correct answer. All right. And I'll just put this here. Yes. Okay. All right. Clear this. And we're doing pretty well on time. Let's go to the next one. All right. So this is a word problem, and it says that a plane can carry passengers, luggage, and mail as long as their total weight is less than 1,700 pounds. Tuesday's load of mail weighs 490 pounds. If the average combined weight of each passenger and their luggage is 170 pounds, what is the greatest possible numbers of passengers that can travel on the airplane on Tuesday? So this is a good problem to use some problem solving strategies on just to reduce the amount of math that you have to do. So they tell us that for one passenger, their total weight is 170 pounds, and that the total weight this plane can carry at any given time is 1,700 pounds. So given that, if this plane was only carrying passengers, then it could carry 10 passengers, but we know that it's also carrying almost 500 pounds in mail. So that means that the answer can't be C because they don't account for the mail. And that also means that it can't be D because, for one, D is greater than C. And also, 170 times 12 is going to be greater than 1,700. So given that, that leaves us with two answer options, A and B. And then how you're going to solve this is to essentially, you can solve this using a systems of equations. The fastest way is just going to be to do it algebraically. So if the total is 1,700 pounds, you're going to subtract the male from that to get 1, 2, comma. Uh, there's no, I put the comma in the wrong place. To get 1,210 pounds. And then you're going to divide that by 170 pounds because that's the combined weight of the passengers and the luggage on this trip. And then that's not going to give you an even number. So instead of rounding up, you're going to round down because it can be greater. It can be up to or equal to 1,700, but it can't go over 1,700. So let's see what people are saying. Okay. Yes, A. So, yes, so give us A. Just doing the math really quickly to make sure. So 1,210. And divided by 1,700. Yep, so it would be 7 point like 11 and change. It would be 7 point like 11-ish, which would be rounded down to 7. Yes, so people who said A, you are correct.
I have a question. What are the fishes that you draw in extra numbers? Like the under choices?
Oh,
It's like a fish.
that's how I draw an X. That's how I'm crossing them out. Sorry. Yes, that's just an X. Yeah, so on to the next. Let's see what the next problem looks like. So we only have a couple minutes left. Oh, we only have a minute left. Okay, so before we leave, are there any questions that you guys have for me about systems of equations, algebra? Again, most of the algebra is going to be these systems of equations questions. Unfortunately, we don't have time for one more, but okay. If nobody else has any questions, I'll go ahead and end this session. Thank you guys for being here. And see you tomorrow, hopefully.